Yes, ma'am.
Okay. Um, right. So what we had done in the last two classes were our comparators. Okay, we dealt with comparators and multiplexers. Okay, so I hope that part was clear to everyone. Is there any doubt in the PDF what I have sent? Is there any doubt in that or anything you have not understood? Everything was
Ma'am,
clear?
yes, ma'am.
Okay, right. So today we'll start with adders. Okay, so see adders, these are digital computers, see perform various arithmetic operations. So it's a simple addition. Okay, so simple addition, how it is? 0 0 gives you 0, 0 1 gives you 1, 1 0 gives you 1. Okay, 1 1 is what? In our regular addition, what is 1 1? 1 plus 1 is 2. Okay, so in binary we represent 2 as 1 0. ठीक है? Is that okay?
मैम और एक बार बोले, समझ में नहीं आया ठीक से.
It's regular addition. ठीक है, regular addition में क्या करते हैं हम लोग? Just a minute, huh? Yeah. In regular addition, what we do? 0 plus 0 is what? 0. Regular addition, हाँ? 0 plus 1 कितना होता है?
1
1 plus 0?
1
1 plus 1?
1 0.
2 ना? 2 को हम कैसे रिप्रेजेंट करते हैं in binary? How do you represent 2 in binary? 0 0 is 0 0, 0 1 is 0 1, 1 0 is 1 which is equal to 0 1, 2 is represented as 1 0. Do you remember?
yes ma'am.
ठीक है, so यही बात इधर लिखा है मैंने. The same thing I have written here. Okay, 1 is represented as 0 1, 1 is represented as 0 1. However, 1 1 is represented as 2, which is represented as 1 0. 2 is 1 0 in binary. Okay, so the first three of अभी तक समझ में आया?
मैं
This good?
मैम आप स्क्रीन प्रेजेंट कर रहे हो मैम,
हाँ,
दिख रहा
यार
नहीं है.
विजिबल नहीं है क्या? एक मिनट रुको.
मैम,
Now,
yes ma'am, visible.
okay, right? So this is what I told you. Okay. So the first three operations produce a sum whose length is 1 bit. Okay. It means, see, 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1, 1 plus 0 is 1. Okay, first three operations. See, the first three operations produce a sum whose length is 1 digit, but when the last operation is performed, the output you get is 2. Okay, see, the output what you get is 2. It means it's a sum is of 2 digits. Sum is of 2 digits. Okay, so the higher significant bit, इसका जो higher significant bit होता है, we call it as a carry. Okay, and the lower significant bit is called as sum. Okay, इसका 1 plus 1, let's leave these operations because output of these three operations is a single digit number. Okay, whereas 1 plus 1 gives you 2, which is represented as 1 0. Okay, so 1 0 in 1 0, right? The higher significant bit which you are seeing here is called as carry, and the lower significant bit will be called as a sum. Okay, so the logic I'm talking about the digital computers, okay, which perform various arithmetic operations. Okay, so the logic circuit which is doing this operation only on this 2-digit numbers or 1-digit number and giving you this, right? This is a half adder. Okay, 0 plus 0, 0, 1, 1, 0, 1, 1. ये जो additions कर रहे हैं, these all are my half adders. Okay. See, okay, the logic circuit that performs the operation is called as half adder. However, the circuit which performs addition of 3 bits, okay, is called as a full adder. Okay, understood the difference between half adder and a full adder? I'll explain you once again. Okay. Okay. Right, you will first see what is a half adder. Okay. So see, the half adder operation needs 2 binary inputs and it generates 2 binary outputs. Okay. So what I'll do here, I'll take a truth table. Okay, I'll take a truth table. I have 2 inputs and 2 outputs. Okay, so we are now doing what is called as a half adder. Okay, we are doing the half adder. So half adder is a circuit which is having 2 inputs . Okay, half adder is a circuit which is having 2 inputs. Okay, A and B, and it will have 2 outputs which would be carry and sum. Okay, up till here was it understood? यहाँ तक समझ में आया what I am telling?
Yes, ma'am.
Okay, so see, we'll write 0 0, 0 1, 1 0 and 1 1. Okay, now we'll see how the operation is performed here. Okay, now 0 plus 0, what is the answer? 0 plus 0 is?
Zero, ma'am.
So your 0 plus 0 is 0. Okay, so your sum is 0. Is there any carry involved in this?
No, ma'am.
No. So your carry is also 0. ठीक है, समझ में आया?
Yes, ma'am.
Now, what is 0 plus 1?
1. Sum 1, carry 0.
Yes. So your sum is 1 and there is no carry involved. So my carry is 0. Similarly, 1 0. What is 1 plus 0?
1, carry 0.
Summation is 1, sum is 1 and carry would be 0. Okay. Sorry, last is 1 1. Na? Okay. Now, what is 1 plus 1? See,
2.
like here, 1 plus 1 is actually 2. So what we do, I told you that the higher significant bit is called a carry. So here higher significant bit is 1, okay, and the lower significant bit is 0. Okay, so carry would be 1 and sum would be 0. समझ में आया? This is a truth table for a half adder circuit. Is this understood?
Yes, ma'am.
Anyone
Yes,
wants
ma'am.
me to explain this once again, or is it understood? Prajwal, is it
Understood, ma'am.
okay, right? So this is your half adder circuit. Okay, so this half adder is also called as binary half adder. Okay, this half adder is also called as binary half adder. Okay, So this is the truth table of half adder. Okay, this is the truth table for half adder which I explained you here. Depending on this, I have put the block diagram. As I said, a half adder is a circuit which is having two inputs and it generates two output, carry and sum. Okay, so for this carry and sum, now what we'll do, we'll put the K map. Okay, so carry के लिए we have put the K map, right? A and B are inputs. So carry is 1 only for the combination 1 1. So 1 1 की जगह 1 डाला मैंने. Okay. K map, you all are able to understand the K map?
Yes, ma'am.
Yes, ma'am.
So when you simplify this K map, we get carry as AB since there is only one here. And for sum, when you put K map, see, sum is 1 for mean terms 1 and 2. Okay, for the mean terms 1 and 2, our sum is 1. And when you simplify the K map, the SOP you get as A bar B plus AB bar, which can be written as A XOR B. Okay, so depending on these two expressions, what I have got from the K map, I have put the logic diagram. Just go through it. Is there anything to be explained? Anything to be explained or is it understood?
Understood, ma'am.
Okay, see the carry I have directly taken A dot B I have taken as carry and A XOR B I have taken as sum. Okay, so this is a half adder circuit. Now similar to, see, in a half adder circuit, what happens? Here I got one more one. Okay, carry आ गया one. So if carry comes, okay, it means there is a 3 bit. Okay, so half adder ka limitation is, limitation of a half adder is, see, addition of 3 bits is not possible here. Okay, addition of 3 bits is not possible in a half adder. Okay, so this is the reason why we do not go for half adder. Instead of half adder, what we do, we go for full adders. Okay, so was this understood up till here?
Yes, ma'am.
Janvi, any issues? Janvi, Shraddha?
No, ma'am. No issue.
Okay. So same thing. Okay, same thing. Now I've asked here, draw a half adder using NAND gate. Okay, this is from the previous year question paper. They have asked to draw a half adder using the NAND gates. So first, when you are asked to do this, first work is you have to put the truth table, which is similar to this. Okay, you have to put the truth table. You have to draw the K map. Okay, you have to draw the K map. Again, you will get carry as AB and sum as A XOR B. Okay, up till here you have to do. See, this part remains same. Okay, up till here it remains same. Carry calculate किया A dot B, sum calculate किया A bar B plus A B bar. ठीक है, यहाँ तक ठीक है. Up till here is it understood? It is same as what we have done now. ठीक है. Only thing we have to do is we have to implement it using NAND gates. Okay, you have to implement it using NAND gates. So what we'll do is, see, there is carry is given, okay, carry is given as A dot B. Okay, carry is given as A dot B. Okay, Now if I put a bar here, what it would be according to De Morgan's theorem? It would be A bar plus B bar ना, D bar अपना De Morgan's theorem, do you remember? Okay, ठीक है, right? Now see, what I mean to say is, if I put only one bar, it would change the value. Okay, so instead of that, what I'll do, I'll put two bars here. तो क्या हो जाएगा? This bar will cancel out this bar. समझ में आ रहा है? Understanding?
Yes, ma'am.
So what I have done here, I have put two bars. So that the value of AB will not change. When you put two bars, the value of AB will not change. Okay. So what I have done here, A, B, double bar I have taken. Okay, A, B, double bar I will take. Similarly, some expression is what? Some expression is A bar B plus A B bar is my sum expression. Okay. Now what I'll do, I'll simplify this because I have to construct a logic diagram in which I should represent it using a NOT gate. So what I'll do, again here also I'll put double bar. Okay, so A bar B plus AB bar double bar. समझ में आ रहा है? What I have done here, instead of putting one bar, if I put only one bar, my value will change. So what I have done, to avoid changing of my value, I have put double bar, which will cancel out each other and which will not alter the value of main function A bar B plus AB bar. Okay, यहाँ तक समझ में आया? Understood up till here? See what I have done here, A bar B plus AB bar. For that I have put two negations. Okay, I have put double bar. Is it understood up till here?
Yes, ma'am.
Okay, now we go on simplifying and we end up at, we get A bar B bar dot AB bar whole power bar. Okay, now this is the form when I can implement the half adder in the NAND gates. Okay, so a same carry is what? A B double bar. Okay, so what I have done, carry के लिए, see I have brought A, I have brought B, I have used a NAND gate. Output of NAND gate is A B whole bar. Okay, and this I have given to one more NAND gate which will give me a double negation. It means it is AB which is equal to carry. ठीक है, समझ गया up till here? Understood up till here? Carry?
मैम बट डबल बार यूज क्यों करेगा मैम इसमें?
बिकॉज क्वेश्चन में बोला है कि NAND गेट से इम्प्लीमेंट करना है. इफ यू आर नॉट,
ओके, नैंड
अभी
गेट
अगर NAND गेट नहीं बोलते थे तो हम लोग ये रेगुलर गेट यूज कर लेते थे. वन इज AND गेट, वन इज XOR, ये करके हमने इम्प्लीमेंट किया. बट हाँ, but now
Yes,
they are
ma'am.
asked, we are asked to implement using NAND gates. So any equation you want to implement, any Boolean function you want to implement using NAND gates. NAND means what? AND के आगे bubble. Okay, so if I directly see, अगर I have a equation, I have a Boolean function. Okay, A dot B है मेरे पास. Okay, I have a A dot B. How I would implement this? using a NAND gate. Okay, I would take A, this was my A, this was my B, a simple AND gate I'll take. Okay, right? This is a function, right? Output क्या है तुम्हारा ये? A dot B. Agree for this?
Yes, ma'am.
Now, अगर मैं बोलती हूँ कि you implement A dot B using NAND gate only. Okay, now my thing is I have to implement this using NAND gate. Okay, so that is why what I'll do is first I'll take double bar, क्योंकि single bar लूंगी, single negation लूंगी तो value change हो जाएगा. So double bar लेती हूँ मैं. What I'll do, I'll implement A and B. Okay. फर्स्ट मैं क्या करूंगी, मुझे बार चाहिए फर्स्ट, तो मैं पहले एक NAND गेट डालूंगी. इसका आउटपुट क्या आएगा मेरा? ए बी बार आएगा. करेक्ट?
Yes, ma'am.
हाँ, और एक NAND गेट डालूंगी तो मेरा क्या आ जाएगा? ए बी, या तो मुझे ए बी आएगा, else I can also call this as AB double bar, okay, which is same as my main expression. ठीक है? So whenever an Boolean function is given and you are asked to implement it using a NAND gate, your first work is to do this. Okay, you have to put a double bar so that its value will not change. ठीक है?
Yes, ma'am. Got it, ma'am.
Okay, right? Right, so this is my carry which I have implemented, right? Sum के लिए what I have done, see, A bar B I have sent through a NAND gate, A B bar I have sent through a NAND gate, this both I have sent through one more NAND gate, right? Final expression is A XOR B only. Okay, here instead of using an XOR gate I have used a NAND gate. See, in place of XOR में क्या होता है? We use only one XOR. ठीक है? But when I have to use only NAND gates, then my circuit complexity and the economy increases. See, 1, 2, 3, 4, 5. 5 extra गेट डालने पड़े मेरे को इधर. When I want to implement A XOR B using only NAND gates, I had to implement 5 gates. However, here only one gate was sufficient. समझ में आ रहा है अभी? Is this clear?
Yes, ma'am.
Okay, so this is implementation of a half adder using NAND gates. Okay, so we'll move to next part now. This is what our half adder. Okay, now we'll go to full adder. Okay, now similar to our half adder, I have full adders. Only thing is full adder में advantages carry भी होता है इधर. Okay, you have something called as carry. Okay, so I'll write down the bits 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. Okay, I'm explaining you carry. Okay, see, 3 bits means what? 3 bits means I have 2 input bits and 1 carry. Okay, carry आता है. Are you understanding what is meant by carry?
Yes, ma'am.
So, a full adder, okay, sorry, this is a full adder. Full adder is a circuit, okay, which is having 3 inputs, okay, it has 3 inputs A, B and C in and 2 outputs carry and sum. Okay, there are 3 inputs and 2 outputs. Okay, now how to perform this addition? Now what is 0 plus 0? 0. Again 0 plus 0 is 0. So your sum is 0 and carry is 0. ठीक है? समझ में आया? This first one is clear?
Yes, ma'am.
Now, second, 0 plus 0 is 0. 0 plus 1 is how much?
1.
So your sum is 1 and your carry is
0.
0. Okay? Now, third case, 0 plus 1 gives you 1. 1 plus 0 also gives you 1. So what I'll do, I'll retain this. Any issues up till here? इन तीनों का कुछ problem हो or understood?
Understood, ma'am.
Okay. Right. Next one. Now, 0 plus 1 is what? 1. ठीक है? 0 plus 1 is 1. What is 1 plus 1? 2. Correct? 1 plus 1 is 2. It means I have 1 carry. How do you represent 2? 1,
1 0.
1 0. See? समझ में आया अभी? Understood this?
Yes, ma'am.
Okay. Now 100 is again 1 plus 0 is 0. Sorry, 1 plus 0 is 1. Again 1 plus 0 is 1. Okay, so there is no necessity of a carry. Okay. However, 101 के लिए, see 1 plus 0 becomes 1. 1 plus 1 becomes 2. 2 is represented as 1 0. Okay. Similarly, see 1 plus 1 is 2. 2 plus 0 is 2. 2 is represented as 1 0. Okay. Now 1 plus 1 is 2. 2 plus 1 is 2 plus 1 is 3. 3 we represent as 1 1. देखो, any issues in understanding this? Understood this? Anyone wants any explanation here?
No, ma'am. Understood, ma'am.
Okay. Others?
Yes, ma'am. Understood.
Okay. Shall we proceed?
Yes, ma'am.
Yes, ma'am.
So now again, like half adder, इसके लिए भी what I have to do? I have to see it's a full adder. Okay, a full adder is a combinational circuit that performs arithmetic sum of 3 input bits. It consists of 3 inputs and 2 outputs. Okay, now see 2 input variables denoted by A and B represents 2 significant bits to be added. Okay, so as I said you, A and B are the significant bits which we need to add. A plus B we do first. C in is called as carry bit. Okay. See here, the third input C in represents carry from the previous lower significant position. Okay. पहले का कुछ रहा, from that if you have carry, that is taken as a third input. Okay. Now this is a circuit which is having 3 inputs A, B, C in and 2 outputs C out and sum. Okay. Now this is what? See, this is the truth table which we discussed just now. Okay. I hope this was understood. The truth table was understood, everyone.
Yes, ma'am.
Okay. Now, abhi similar to half adder, what I have to do? I have to implement it. Okay. Similar to half adder, I have to implement the full adder. So implementation के लिए I want expression for the outputs C out and summation. So what I have to do? I have to first construct the K map. So I put the K map for C out. Okay, C out के लिए K map है. A, B and C I N have taken here. See, carry is 1 for 0 1 1, 1 0 1, 1 1 0 and 1 1 1. See 0 1 1 1 0 1 1 1 1 and 1 1 0. इनके लिए 1 है. So I did the grouping of cells and I have written the equation for C out. Can this be done? समझ में आया? कुछ प्रॉब्लम है इसमें? Is there any problem in understanding C out equation? C out समझ में आया? What is this? See, truth table is clear, everyone. Truth table is fine.
Yes, ma'am.
Understood the truth table. Then is there any problem in understanding the K map?
No, ma'am. K-map is also understood, ma'am.
Okay. So see, this is a K map for carry, one of the outputs, C out, and this is the K map for another output, which is sum. Okay, so there are two outputs. One is for K map, one is the K map for C out, one is the K map for sum. Okay, so once we have got the expression, okay, we got the expression. Next, what we did, we have done the SOP implementation. Okay, see, C out is what? AB. C out, what we have got here? A, B plus B, C in plus A, C in. Okay, see AB, A, C in plus B, C in. So I have used one more OR gate so that I get C out. Similarly, sum ka expression I get A, see, I have to put the K map. From this K map, I get individual ones. So I get 4 mean terms. A, B bar, C in bar, A bar, B bar, C in, plus A, B, C in, plus A bar, B, C in bar. Okay. So the same thing I have implemented here. Okay. ये हुआ तुम्हारा SOP implementation. Now, इसके बाद the sum I have taken here. Okay, the same expression जो भी मिला है, I'm again simplifying it. See, because here how many gates I have used? 1, 2, 3, 4, 5, 6, 7, 8, 5, 6, 7, 8, 9 gates I have used. Okay. So now I have to reduce the number of gates. So मैं क्या की? For some expression, I reduce the sum expression as C, A XOR B XOR C. Okay, A XOR B XOR C. So see, here I had used 5 gates. Okay, 4 AND gate and 1 OR gate. But now after simplification, I am using only 1 XOR gate, which gives me sum, which is A XOR B XOR C. Okay, C in, C out, same like this. ये जो इधर implement किया है ना, same I have implemented here. Okay, so this is how you implement a total full adder circuit. Is this understood? Anyone needs the explanation for this?
No, ma'am. Understood, ma'am.
So, see, this was the implementation of full adder. Okay. So, have you understood half adder and full adder now? What do you mean by half adder and what do you mean by full adder? It's truth table and the circuit diagram. How do you implement it? Have you understood, everyone here?
Yes, ma'am.
Okay, right? So the same half adder. See, इधर क्या बोला मैंने? Here, when I was explaining you half adder, I told you the disadvantage with half adder is what? If one more carry bit comes, I cannot use a half adder. Okay, so एक carry bit आया तो what I'll do? I'll go for a full adder. Okay, I'll do what? I'll go for a full adder. It means what? I can implement a I can implement a full adder using two half adders. Okay, so I can implement full adder using two half adders. So what you have to do is, see, full adder can be implemented using two half adders and one OR gate. Okay, I need a OR gate at the output to get the C out. Now the sum output from the second half adder is exclusive OR of C in and the output from first half adder. So what I'll do, see, this is my first half adder. First half adder किधर है? Where's my first half adder? See, it is up till here. Up till here. You all can see it?
Yes, ma'am.
हाँ? See, इधर क्या आएगा आपका output? A XOR B would be your output. Okay? A XOR B would be your output here. And what would be output here? A dot B. Just see. इधर output क्या आएगा आपका? A XOR B. Correct? इधर output क्या आएगा आपका? A dot B. So see what if I show you the half adder. See, sum was A XOR B and carry was A dot B. Okay, so this is my first half adder. Okay, ये मेरा हुआ first half adder. So A XOR B I will take to the next XOR and the second input of that XOR would be C in. So मेरा here for the second half adder, my sum would be C XOR A XOR B. Okay, C XOR A XOR B, and C out would be C in dot A XOR B. See, इधर से from here what is the output? A dot B. Okay, A dot B is coming here. Okay, and from here I am getting A XOR B and C in. So here it is C in A XOR B and here is my AB. Okay, so your C out would be AB. Here I have written, see here, C out would be AB plus C in dot A XOR B. समझ में आया? How I can implement two half adders to get one full adder? Is this understood?
Yes, ma'am.
Okay, right? So you can, so that is what I have written here is, right? If we go on increasing the number of variables, okay, abhi see, this is the truth table for a 3-bit. Okay, this is the truth table if I want to add 3 bits. Now you think if you want to add a 4-bit number or 8-bit number. Okay, so see, if see, more often there arises a need to add 2 4-bit or 8-bit numbers. Okay, so there may be no necessity to add more numbers, which would increase the magnitude, okay, of the truth table. So what we do instead of, see, अगर 8-bit का, see 3-bit के लिए तुम्हारा truth table नहीं है. Okay, this is a truth table for 3-bit. Means what? 8 rows. Okay, 2 power 3 rows. Now, if it is a 8-bit, then how many rows you will require? See, 3-bit के लिए I require 8 rows. So for 8-bit, how many rows would I require? Huh? 8 is what? 2 power 3. Okay, 8 means what? 8 rows means what? 2 power 3. Right? So 3 variables के लिए 2 power 3 rows डालने पड़े मुझे. सो 8 बिट वेरिएबल के लिए मेरे को 2 पावर 8 रोज डालने पड़ेंगे. 2 पावर 8 रोज मीन्स 256 रोज. 2 पावर 8 इज 256 रोज. ठीक है, तो तुमको ऐसा ट्रुथ टेबल 8 बिट वेरिएबल के लिए 256 रोज का डालना पड़ेगा. समझ में आ रहा है? अंडरस्टैंडिंग?
यस मैम.
So instead of that what we do is ये जो हाफ फुल एडर्स होते हैं ना, वी गो फॉर कैस्केडिंग द फुल एडर्स. सी, वन अप्रोच इज टू कैस्केड द फुल एडर्स टू कॉन्फ़िगर मल्टीपल बिट एडर्स. ओके, सो मेरा ये 2 बिट एडर हुआ. ओके, दिस इज अ 2 बिट एडर, दिस इज अ 2 बिट एडर, दिस इज अ 2 बिट एडर. Okay, so what I do, I go on cascading each full adder so that I can go for adding 4-bit numbers, 8-bit numbers, or go on increasing 32-bit, 62-bit numbers. ठीक है? So I go for cascading of adders. Is it understood up till here?
Yes ma'am.
Okay, right. So this was about adders. Similar to adders, we have subtractors. ठीक है, subtractors we'll see it in tomorrow's class. Okay, but what we did today, was it clear everyone?
Yes मैम.
Okay.
मैम वो असाइनमेंट में वो सभी सॉल्व करने हैं मैम.
It's better if you do.
वो सभी सॉल्व करना है मैम.
अभी जो मैंने पीडीएफ भेजा है ना आपको,
हाँ सेकेंड पीडीएफ मैम. यस.
नहीं, whatever after first आई अभी जो what I have sent you the question bank.
हाँ.
Okay, all answers are there in whatever PDF I have sent you.
मैम मतलब वो फर्स्ट एक पोर्शन के लिए आपने भेजा था, वो सेकंड मॉड्यूल एंड थर्ड मॉड्यूल बोथ के लिए भेजा था. उसके बाद और एक भेजा था, उसमें सेकंड मॉड्यूल का पोर्शन डाल के भेजा था मैम.
हाँ.
उसमें वो सेकंड वाला लिखना है ना.
हाँ, दैट इज योर सेकेंड आई ए क्वेश्चन बैंक. ओके, जो मैंने सेकेंड टाइम भेजा था, दैट इज योर सेकेंड आई ए क्वेश्चन बैंक.
ओके मैम.
हाँ, एंड इफ यू वांट आंसर्स फॉर दैट क्वेश्चन बैंक इज ऑल इन द नोट्स. ओके, वॉट एवर नोट्स आई हैव सेंट यू, उसमें सारे आंसर्स हैं.
ओके मैम.
हाँ, तो वो कर, यू फिनिश योर इंटरनल्स. ओके, इंटरनल्स फिनिश करो, नेक्स्ट मंडे तक सबमिट करो, चलेगा? Right, so today you go through that assignment. If you have any difficulties, tomorrow's class will discuss the question bank. Okay?
ओके मैम. ओके.
Okay, you all can quit for today.